An isotopic species of lithium hydride. It's not visible here. The question is, Li6H2. What is the normal species of lithium hydride? It is LiH. Now it is an isotopic species of lithium hydride, Li6H2, is used as potential nuclear energy fuel following the nuclear reaction. That is, your Li combines with hydrogen, that is your deuterium, forming what? Helium, that is two atoms of helium. And of course with lots of energy, right? Now what you need to find out? Calculate the expected power production of megawatt associated with 1 gram of equinuclear mixture per day, assuming 100% efficiency. It means what? Whatever energy is produced here, it is 100% converted to energy, right? Now what you need to find out first is how much energy is released. How can you find out that? We can find it out. I'll take my question here. I'll put the values over here. I'll put the reaction over here. This answer 5. And it is what? The lithium 6,3 is combining with hydrogen 2,1 and is forming what? 2 atoms of helium. Right? Given as isotopic mass of Li6 is equal to 6.01521 atomic mass units, isotopic mass of deuterium is equal to 2.01410 AMU, and isotopic mass of helium is how much? 4.0026 AMU. Now if I want to find out the energy, my question is that when there is 100% efficiency, it means what? When all the energy produced in this reaction is converted into the potential energy, how much energy is produced? First let's find out how much energy is produced. So energy is equal to delta M into 931 mega electron volts, right? So what do you need to find out first over here? You need to find out delta M. Now what is delta M? Your delta M would be equal to the mass of lithium, right? That is the mass of lithium plus the mass of hydrogen, and that is to be subtracted by the mass of helium. That is the reactants minus the products. So let's see this. It is 6.0151 plus 2.01410 minus, it should be 2 multiplied by 4.0026. So what will be our delta M equal to? It should be 6.0151 plus 2.0140, that is equal to 8.0291 minus 2 into 4.0026. That would be equal to 8.0052, and that is the mass defect, right? Now 8.0291 minus 8.0052 will be equal to how much? 0.0239 AMU. Right? Now this is your mass defect. How will you find out the energy now? The energy will be equal to 0.0239 multiplied by 931. So how much we are going to get here? It is 0.0239 multiplied by 931. So we are getting 22.25 mega electron volts. Now students, we have got the energy in terms of mega electron volts. But in what terms your energy is asked? It is asked in megawatts. Right? In megawatts per day. Now, so this is the energy produced by one atom or the one molecule of lithium hydride. Okay. Now, what is the energy produced per mole? This is the atomic energy. Now, what we need to find out is the energy per mole. Then only we can find out how many grams. 1 gram is producing how much of energy? So, energy per mole would be equal to what? Now, how many particles are there in 1 mole? It is 6.023 into 10 to the power 23. Right? So, it would be 22. I think we should first convert mega electron volts into joules. Right, that should be the better part. What was this? 8 point, right? So how I'll convert this mega electron volts into joules? Do you know that? 1 mega electron volt will be equal to 10 to the power 6 into 1.602 into 10 to the power minus 19 joule. So your 22.25 mega electron volt will be equal to 10 to the power 6 into 1.602 into 10 to the power minus 19 into 22.25. Right? What I'll get here? Let's calculate. It is 10 to the power 6 multiplied by 1.602 multiplied by 10 to the power 19 multiplied by 22.25. And that will be equal to how much? 3.56 into 10 to the power minus 12 joules. Right? Now we have got our energy in joules, that is produced in per atomic. Now what is required? What do we require now is the energy produced per mole. So, why we want to find that? This is for per atom we are finding. But in a reactor where this energy is converted into potential energy, there are a large number of atoms, or there we talk of energy in terms of weights, in terms of grams. So we want the energy in terms of grams, that 1 gram of lithium is converted into how much of energy? Lithium hydride, sorry. 1 gram of lithium hydride is converted into how much of energy? So, energy per mole. Right? In 1 mole, how many particles are there? 6.023 into 10 to the power 23. So the energy produced by per mole would be 3.56 multiplied by 10 to the power minus 12 into 6.023 into 10 to the power 23. Now that is equal to how much? It will come approximately equal to 21.55 into 10 to the power 11 joule per mole. Right? Now we have got the energy in 1 mole. Fine? Now, what we want? We want energy per gram. How will we find out? First of all, lithium hydride. How many grams of it are there? That is, what is the atomic weight of this? It is 8. 6 of lithium and 2 of hydrogen. I'm not talking of isotopic mass. So, the energy produced for 1 gram would be (21.55 into 10 to the power 11 divided by 8), and that will give you what? This will give you per gram, right? And per day also. How will you find out per day or per second? I think it is in megawatts per second. So let's find out. This would be the energy produced This is actually a long question, but it's actually simple also. Energy produced for 1 gram of Li6H2 per second will be equal to what? 21.55 into 10 to the power 11, and that has to be divided by 8 multiplied by how many hours are in a day? 24 hours, so it should be 24. That multiplied by the seconds, that is 3600. In 1 hour there are how many seconds? 60 seconds. 3600 seconds. So in 24 hours there will be how many seconds? 24 into 3600. Now this will give us the energy in joule per gram per second, and that is equal to 3.12 into 10 to the power 6 watts per gram. Now our answer is still not complete. Is the question asked in watts per gram? What is watt energy? Watt energy is joules per second, gives you watts. Right? What is measured as the energy per second is watts. Now we want the energy in megawatts. So what will be the energy in megawatts? It would be 3.12 megawatts per gram. So this reaction, this particular lithium hydride is producing, I can write here that this isotopic lithium hydride, is producing 3.12 megawatts of energy per gram per second, right? And assuming that the efficiency is 100%, that is, there is 100% energy conversion. So this is the way how we find out the answers to such type of questions. Let's move back to our question. I'll summarize this once more. What is asked? We have the isotopic species of lithium hydride, red, and it is converted and is used as a potential nuclear energy fuel. What is expected? The expected megawatt reduction associated with 1 gram equinuclear mixture consumed per day. What you need to first find out, what should be the steps followed? First, find out the mass defect. Second, find out the energy in mega electron volts. Convert this energy into joules. Why? Because you are asked to find out the energy in megawatts. Then find out the energy produced by 1 mole, right? Then find out the energy produced by 1 gram. Then find out the energy produced per gram per second. Then convert the obtained energy in watts to megawatts. So now this many steps are required to solve this question.